And welcome. This is session 3 of strength of material. So here we are going to study about shear stress and complementary shear stress. So what is the shear stress? As it is defined here, that if two equal and opposite parallel forces not in the same line. So here, as we can see in the picture, in this figure, there are two forces that P in figure A. Here you can see in the figure A that two forces that you have taken one plane, that is one section we have taken x and x, and we divided into the two different that due to means by providing the section we have divided into the two sections, and that forces which is acting on both the sections here both are opposite and it's not lying on the same line. So here if the two equal and opposite parallel forces not in the same line and act on two parts of the body, so here it's acting the two different parts of the body for P. Then one part try to slide over. So one part what we will do, one part will try to slide and shear, means it will try to shear up from the other across any section. So at any plane within this area it will try to shear up, and the developed stress is called shear stress, and whatever stresses will develop to have a shear of this section which is called shear stress. So this is also applicable if we have a cantilever section. So here in this cantilever beam type structure we have taken, and one more section is taken in this so here that P load is applied. So as one end is fixed, so it's not a problem. So due to fixity, one reactions will be acting at another side, and one side that load P is acting. So what will happen? Same situation will arise, means this some at any sections this material will try to shear up due to application of forces. So this is happening, and apart from this, when we are taking two material, two bodies which is connected with the this connector, so what will happen if at the two materials if load P is applied, this load P is applied and it is pulled away from both the sides. So what will happen if this connector is not able to sustain the loading? So what will happen? This is going to break, going to shear up. So here this will shear up. So this is the due to the application of forces that material will try to shear up or to try to slide over one another. So this is the concept of shear stress. So due to this, shear stress will develop. So how it will define that? Shear stress tau, so will indicate with the tau. So this is a shear stress that will be load, application of load at the cross section area, okay. And if the intensity of shear stress varies over an area at various points, means whatever shear stress is developed that is not equal at every point, so that can be defined as tau is equal to delta P by delta A, means at different points that loading will be different and area will be different, so shear stress will be different. Next we will go for complementary shear stress. So this one we did, this one we did. So now we will go for complementary shear stress. So how we will define the complementary shear stress? For this need to take a solid body, then, and this is a elemental, one element need to take from a solid body. So an elemental area ABCD. So this is the A, B and CD here we have taken is considered under shear stress, and shear stress is applied on the face AD and BC. So here shear stress of intensity tau acting on planes AD and BC. Here shear stress acting on the element tend to rotate the elemental block in clockwise direction. So this is applied in this way and this is applied in this way. So what it will do, it will try to rotate in clockwise direction, okay, but it will try to rotate in clockwise directions. That's why what will happen, only shear stress is acting on the plane AD and BC and other forces are acting on the element, okay. So this elemental block will rotate in clockwise direction. So to maintain the equilibrium, what will happen here, to attain the static equilibrium of the element, another couple of the same magnitude is applied. Means same magnitude is applied means again one shear stress is applied in different directions. Same magnitude is applied in anti-clockwise direction. So then what will happen, again we will see through this diagram. So as for this element we have taken here that AB, that distance length is x and BC length is y, and here shear stress is applied. So if you see here that in counterclockwise directions one shear force, a shear stress tau dash will be applied. So here x and y is the length of the plane AB and BC as we have given here of rectangular element and having unit thickness. So here you can say that it has a unit thickness. So it's not, you can locate here that having unit thickness. Okay, so this element having unique thickness, we can say this is, you can say 1. So now we'll define the force on the face. How will defined? So area into shear stress. So shear stress is acting tau on face AD and BC. So force on the couple tau. Shear stress is acting on the face, and with the unique thickness and that length is y. So what will be the area, as it is a rectangular cross section, C y into 1, tau into y into 1 for face BC, here for BC, or same way we can take AD also. So force on the couple into x. So now force we have defined. Now moment of the given couple is force on the couple into x. X is the distance, perpendicular distance. So here moment we define. Again a shear stress acting at the perpendicular of the AD and BC. For that similarly we will do the calculation. So the force on balancing couple. So force on balancing couple means AB and DC. So here balancing shear stress is applied to maintain the equilibrium. So here tau dash into x into 1. Here also thickness is 1 and x is the length. So here area will get. So like this we will get the force on balancing couple. So force will get. Now moment on the balancing couple is tau dash into x into y. So as we are considering the equilibrium condition, means both the moment will be equal, then it's going to maintain the equilibrium condition. So what will happen, that tau will be equal to tau dash. So here you can see that tau will be equal to tau dash. Next what we will do, so let us see how it's happening. What will happen if a shear stress is applied at the one plane of the body, then there must be an equal and opposite shear stress is applied over its perpendicular plane, that is known as complementary shear stress. So how we are defining the complementary shear stress? So thank you, and we'll end this session now.